Thank you very much. Thanks for having me. I'm just going to share my screen to show our presentation. Can you see the presentation? Hello?
Yes, we can.
Yes, we can.
Okay,
Yes.
that's great. I thought I was on my own for a second.
Yes, we can see.
So yeah, we are a manufacturer in Cape Town, South Africa. We've been operating for about 5 years now. When we started manufacturing cross-laminated timber, we were the only manufacturer in the market. In fact, there wasn't really a market here. There were a few European companies who were trying to export stuff to South Africa and a few buildings that had gone up, but nothing that was really in an affordable range, and quite difficult to manage those projects over such a far distance. It is possible, they do it quite often in Europe, but the market here wasn't really something that they were focusing at. So I did a trip around Europe and visited a few of the factories there, and I must say that they were very helpful and friendly in helping us to get the information that we needed. And then we decided to start manufacturing. So my background is in architecture. I was an architect, so I did have an understanding of what the market required. And I had also managed a furniture manufacturing facility, a timber furniture manufacturing facility. So I kind of already was in the pathway for that. We initially started by building our own press. So we had looked at purchasing machinery. But as you can see in the videos, the European spec type of manufacturing facility is a huge capital cost. You're talking tens of millions of dollars to set up a facility like that. But we have seen that there's a way to manufacture cross-laminated timber on a smaller scale. And for the African market and a market that's kind of just starting off, we think that it's a good option to an easy entry into the market. So let's take a look through the slides that we have here. We, from the beginning, wanted to make sure that there were certain elements covered. And because we were first to market and the first manufacturer, there's a lot of hurdles or barriers to entry. The biggest barrier was the standards. So I'm sure Nigeria has its own specific building standards and recognizes certain materials. South Africans has SATIS or the SAN standards. And to build with materials which aren't in those standards is quite challenging. You get a lot of issues during your submissions to council and for approvals. So it's difficult to get it through. So the first stage that we saw was to tackle that standards. And yeah, to get a national standard in place is not an easy task. And we actually helped one of the universities here, one of the big universities here, to push it through. There was also some backing by the certain government organizations. They can see, like the Department of Trade and Industry in South Africa had already identified mass timber and engineered timber as an important product, which would increase the forestry sector, which makes up 1% of our GDP. So with the university and with kind of these parastatal or these state organizations, we managed to push the standards and get something in quite quickly. So quickly is 3 years, but we still did get something in. So South Africa now has a national standard, which is actually a copy of the Canadian and American standard. It's a clone of that. Also very similar to the ISO standard. So yeah, you know, it is a good standard because it is relatively easy. It's not a huge document to get through, and it is the ISO standard as well. It's pretty much equivalent. So the SATIS is the certification we got. The other key things that we needed to make sure of was that our timber supply was coming from sustainable resource. So we are actually FSC approved. and make sure that all of our stuff comes from a sustainable resource. And then we had to check the timbers that we could use to produce CLT here. So I'm not 100% sure what timbers would be used in Nigeria, but in South Africa, the major plantation timbers are SA pine, which is a mix of kind of radiata pine, Ellioti, patchouli, and then quite a large portion of eucalyptus, grandis, and saligna. So the pine is the cheaper option here and maybe the more suitable option at the moment. And we went for that as our major material, but we do eucalyptus panels as well. We also found that fire was a huge issue. Like it's not an issue with the mass timber itself, but it was an issue with the certification in the country. So there's a lot of documentation and information about how good mass timber is in a fire situation and how it will stand up and all of the properties of that. But because there wasn't a South African version of this, a local study of this, it was causing trouble. So we actually went through the universities again and got a study done like that. So these are kind of duplicate studies of what's been done internationally, but I think it's important for a country to have its own standards. It makes it much easier to pull through. This is just a diagram about what CLT is. I'm sure you all understand this already. We manufacture from SA pine, as I said, and we built our own press, which is a vacuum press system. So the vacuum press system, it works on differentiation of atmospheric pressure and kind of sucking of the panel down or the evacuation of the air rather than a larger production machinery, which is kind of what was just shown, the hydraulic presses or the pneumatic presses. So the hydraulic and pneumatic press are amazing, very strong, give you an incredible product, but they come at a huge cost. And they need a lot of kind of support machinery in order to feed that press, because for the price that it is, it's got to be producing constantly. We found with the vacuum press, we're not going to get close to the production volumes that a larger factory like the Exlam Australia guys would, or the Binderholz guys would. We are a small scale manufacturer, but we can grow quite easily and at quite a reduced cost of entry. So I wouldn't say that the vacuum press is any better than the hydraulic press. I probably think in long term, a hydraulic or pneumatic press is better. But once you're building up to a certain volume, maybe 10,000 cubes or 15,000 cubes, then it starts making sense to move across to another one. So it is possibly a stepping stone and an easy entry. There are some big factories in Europe that are using vacuum press. It is still a great system and you can use it for high-end production. There's a whole range of mass timber products, glue laminated timber, dowel laminated, LVL, parallel strain, nail laminated, all of the different ones. We specifically have focused on cross laminated timber. It is very similar to glue laminated timber in its production process up until the actual pressing. So there is possibility to do both of these, but we specifically have just decided to focus on the cross laminated timber. Again, this is just the standards. We had the standards in place. We got the fire certificates and testing done, and we have structural testing done. So we had to cover all of those bases with the materials. And in any new environment, this is kind of the key things that you have to do. You have to identify the timber and start getting these standards in place. We did manufacture before we had standards, and we actually built quite a few buildings before there was a standard in place, but it just makes it that much easier once there is a standard and it is a recognized material. Mass timber have got huge potential for solving a lot of problems that are found in the construction industry. And it's not all about the timber itself, it's kind of what the timber can do in its system. So because you are manufacturing off in a factory and to different levels in a factory, you could do just the panels, you could do full build-ups with the cladding on it, or you can, and we have done before, entire modular buildings which are then transported to site. So that allows you to increase your construction speed quite considerably. The material is kind of a finished material as it is. It is a structural material. We found there's a lot of issues here in South Africa where people see this CLT and they're looking at kind of Arc Daily and those type of websites and seeing beautiful CLT. It is a construction material, and it is ideally a structural material. So you can use it as a finished material, but it does take some additional work onto it to make it look good. Carbon sequestration, the environmental side of CLT is a whole story in itself. It is kind of the only industrial scale green material that we have. And then, yeah, one of the big bonuses with this type of material is the ability to cut and machine it to very precise shapes and sizes. And this is kind of what you were seeing with the BIM models and the 3D models, where the drawings are coming from architect to engineer to the factory where it's being built. And it's the same drawing the whole way through. We use the same model in each place. So there's also a huge reduction in issues that come with building, you know, the transfer of information and errors that can come in drawings. And so it helps to streamline and make those processes a lot more predictable. This is just kind of a basic explanation of how the projects are planned. I was an architect myself, and I was guilty of it. A lot of the time we would design buildings, and even while it's being built, you're still making changes to the design and updating things. This type of system doesn't work like that. You have to put in that pre-planning process to get the most out of this. If you can do that, your project is going to run beautifully. So it's quite important to have that level of detail, LOD stages in a project, and to be able to look at those. Project must be frozen before it goes to the manufacturing. You don't want to start making changes while panels are in a factory. Then there's different levels of development that a building could come from. This is a detail from Stora Enso showing different ways that they would do it. You can have just flat panels or panels with cutouts. These could be made up into then composites, which are, say, a cross-laminated timber wall with the cladding on top of it, or to the level where you're doing full build structures with glazing and electrics and plumbing and everything incorporated. And that's kind of what you're doing in the factory is at that level, you're screwing these things together and building components to different levels. So yeah, the explanation of how cross-laminated timber is made was very good in the previous presentation. I don't think we need to go too deep into that. This is just kind of showing the different levels of the actual manufacturing. You can just be a CLT manufacturer and not do the sub-assembly value-added portion, but it does help. It's a great add-on to be able to have. This is just a basic run through to show the different processes that are involved in manufacturing cross-laminated timber. The moisture content is one of the key issues with the timber. We manufacture our timber from pre-graded structural timber, so it already is graded as a structural timber before it arrives in our factory. There is the possibility to do that within the factory. Moisture content, very important. You have to do equilibrium of moisture kind of for your factory, and then also keep in mind where it's going to go in the end. The main components of a factory, I would say, is kind of your finger jointing operation, where you are taking planks and extending them. Then there's cutting them to length. Then you would do your molding, typically, where you're putting the planks through four-sided cutters, so you can get very accurately planed all around timber. Then you can do your layups with glue and pressing. So in the previous presentation, you saw that the factory there is highly automated. Our factory has almost no automation. We are kind of hands-on manual the whole way through the process. We've got 15 people in the factory. It's a lot of manual labor, moving timber across from station to station. The layup itself is done by hand. The glue application, we're using the polyurethane glues, but we have kind of a gantry system that is moved through a small motor rather than a fully automated gantry system. So there are ways to find easier entries into the market. The more technology and testing and automation you can put into the process, the smoother it's going to become. So our operation, it takes a lot of kind of hands-on, eyes-on to make sure that the product is coming out the way that it should do. I'm not saying that having no automation is the right thing. I would think that having more automation is the better thing to do, but you can build up to that automation. The one component which is kind of essential is the cutting. Making CLT is one story, or even before that, the engineering and design and drawing and preparing the packages for manufacturing is one story. Manufacturing of the actual panels is another story. And then cutting these panels to a specific size is a big story. We initially started by cutting panels by hand. We had big circular saws and routers, and I can tell you that it's not a good option to do. For the size of the panels and the weight of these panels, you need some form of automation and some sort of mechanical cutting system in that operation. So here you can see the press, kind of the comparison of the two press. The bottom one is the Liedernick X press. That's kind of the press that XM Australia, I believe, have. Made in Slovakia, an amazing piece of machinery. The one above is a Woodtech vacuum press. That's very similar to the system that we have. It's kind of a rubber membrane that goes on top of it and sucks the panel down. You can see in the back corner that there's one shown there. Cutting of the panels, we have opted for an industrial robot. So there's two systems that you could use for this. The one is a large CNC gantry system, and the other is an industrial robot. So the large CNC gantry system is essentially what it says. It's just a supersized CNC with very big motors and tooling on it. This kind of is almost a fully automated system. You can put the drawings and the panels in there and cut exactly to the sizes that you need. A system like this is an expensive system, justifiably so. It's a very high-tech system. The option that we have gone for is of an industrial robot. These are the type of robots that are used in car factories and are a lot more accessible. There are quite a lot of them around, and the second-hand version is very good. This is our robot. We actually purchased it from a BMW factory. The robot system does take a lot more input from our side, but we luckily have had help from Autodesk in programming these robots. So we use this with automated sliding track to be able to cut our panels to lengths and to sizes and to do the detailing. And we use a circular saw and a large router. So we can do probably 70% of what a large automated CNC could do. Kind of these type of things. This is just some of the projects that we've done. This was the Deloitte building in Cape Town. Those were CLT pre-manufactured facade panels that were made off-site and then put in. That's kind of the inside of those panels where you can see the CLT exposed. This is the pre-manufactured type of units. These things were built in the factory, glazing, electrics, plumbing, everything incorporated and then lifted into space. That's kind of one of those units. This is also, it's kind of limited to the size of the unit that you can transport. So, you know, it does need to be a modular system if you're going for larger sizes. But that you can see is kind of the fully exposed CLT internally. Like I did say, it is a structural material, but you can make it look great if you put a bit of extra time into it. This is more typical of what we do, is just panels for houses. They arrive as flat panels and are assembled on site. This is another project. So you can see, even with the machinery that we have, we can manage to make panels up to kind of 200 mil thick. With our press system, we do an 8 meter by 2.7 meter panel. You know, we are planning on building a larger press, so you can get 14 meter panels. But again, transport is a big deciding factor of the size of press that you would need. Lightweight, you know, it does allow it to be combined with other materials. It works very well with steel. Kind of the accuracy in the steel and the timber complement each other. And then even large scale, you know, we do a lot of floor panels. So I think it's an African situation where the cost of labor is kind of low here. So it is not that expensive to get people doing brick work on a building site, which makes it a little bit difficult to compete with that type of material. But for reinforced concrete slabs, we are very, very competitive. That's that same project from the internal. You can see this is incorporated with glulam beams and CLT panels. And then, yeah, multi-story buildings. The speed at which a CLT building goes up is it's mind-blowing. Every time you see it, you can't believe it happened so quickly. So this is a double-story building on a very difficult site, and that's about 3 days worth of work to put that entire building up. And that's us. Yeah, we are XLAM South Africa. There's a few XLAMs out there, but we are XLAM South Africa. And I'm Jamie, and that's my email address and contact details if you would like to get a hold of me. And thank you for having me.